Hello everyone. In this video, we're going to determine the x-intercept and the y-intercept given an equation, and this is the second part. In this part, we are given a quadratic equation in general form. Before we jump into this first example right here, let's have a definition for both x-intercept and y-intercept first. We remember that x-intercept is a point where a graph or a line crosses or touches the x-axis. On the other hand, when we say y-intercept, it is a point where the graph or a curve or a line touches or crosses the y-axis. So let's take this first example right here. Determine the x-intercept and the y-intercept of a given equation below. That is, y is equal to x squared minus x minus 12. The first step that we are going to do here is to change this general form of a quadratic equation into its factored form. In order that we can do that, we're supposed to use the box and diamond so we can factor this out. I'm going to show the work for the box and diamond on the side right here. So this would come out. So first we're going to use the diamond first. So the one that we write on the diamond would be the product of these, the first term and the last term, which is negative 12x squared. And then the middle term will go to the bottom of the diamond. That's negative x. And so we need to determine the factors of negative 12x squared such that if we add them, it's negative 1x. So these factors are 3x and negative 4x. Now we're ready to move on to the box. So we draw the box right here. So we write first term would go to this side right here of the box. So that is x squared. And then the last term will go down here. That's negative 12. And the ones that will go to the diagonal of this box right here would be these two factors that we got. So that would be, I can write the 3x here, and then I can write the negative 4x down here, so that we can go ahead and say that the factors would be x, and this is negative 4. And this one right here would be a positive 3. So these two are the factors of this given equation that we have right here. So then we can go ahead and say that we can rewrite this as y is equal to quantity x. It's going to be x plus 3 and x minus 4. So then we're now ready to determine the x and y intercept. To determine the x-intercept, we set y equal to 0 and solve for x. So in this case right here, I'm going to go ahead and say we let y is equal to 0. So that this equation that we have right here would come out 0 is equal to x plus 3 and then x minus 4. So that, again, part of this is to solve for the x, and that is actually the x-intercept. So in this case right here, we're supposed to use the zero product property. The zero product property states that if a times b is equal to 0, then a is equal to 0 and b is equal to 0. So in this case right here, we can go ahead and say that x plus 3 is equal to 0, and we have x minus 4 is equal to 0. So that we can go ahead and solve for x. So subtract 3 from both sides, minus 3, so that we are left with x is equal to negative 3. On the other side right here, I'm going to add 4 to both sides, plus 4. So then we can cross the 4 out. So x is equal to 4. So these are the two x-intercepts for this function that, or for this graph that we have right there. If we want to change this x-intercept into coordinate form or ordered pair, we can go ahead and write this as negative 3, 0, because again, we have our y set to 0, and then the other one would be 4 and then 0, because then again, the x was 4 and then the y was set to 0. So this is the x-intercept in coordinate form. Now we're ready to move on to determining the y-intercept. To determine the y-intercept, we set x equals to 0 and solve for y. So we can actually use any of these two equations that we have here. It doesn't really matter. We should be able to determine the y-intercept from there. So that we can go ahead and use this first equation that we have here. So let's rewrite this. Again, we remember that in order to determine the y-intercept, we're supposed to set x equals to 0 and solve for y, so that we can go ahead and say that this is y is equal to, that's a squared minus parentheses minus 12, and we set the x equal to 0, and this is 0 right here. So we can go ahead and say that that is y is equal to 0 minus 12. So then our y-intercept is negative 12. So that we can go ahead and put this inside the box. Now I'm going to show you the other way to do this. Again, we let x equals 0 so that we can solve for the y-intercept. We can also use the other equation right here that would still come out the same, or I mean the answer would still be the same. That's gonna be negative 12. So the answer is still the same with the first one that we got here. So we can use either of these two equations that we have here. It doesn't really matter. We still get the same value for y. So our y here, or the y-intercept, is negative 12. If we want to change this y-intercept into its equivalent coordinate form, we can go ahead and say that the y-intercept is 0, negative 12. So this is, we only have one y-intercept for this. On the side, you will see the graph of this equation, y equals x squared minus x minus 12. You will see that there are two x-intercepts. So this graph is touching at negative 3, 0 and 4, 0 on the x-axis. And it's touching one time only on the y-axis, specifically at 0, negative 12. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. In order that we can determine the x and the y-intercept for this, we are supposed to change this to its factored form using the box and diamond. So I'm going to show the box and diamond on the side right here. Okay, so what I did was I factored this 2x squared minus x minus 15 using the box and diamond, and I got y is equal to 2x plus 5, quantity x minus 3. So then we go ahead and determine the x-intercept. To determine the x-intercept, we set y equal to 0 and solve for x. So we go ahead and say let y equal to 0. So using this equation that we have right there, we can go ahead and rewrite this as, okay, in order that we can solve for x, we're going to use the zero product property. The zero product property tells us that if we got a times b is equal to 0, we go ahead and say then that a is equal to 0 and b is equal to 0. So in this case right here, I can go ahead and say that 2x plus 5 is equals to 0 and the x minus 3 is equals to 0. So then we go ahead and solve for x. Okay, so I've shown you the work to in determining for the x-intercept here. So the first x-intercept is negative 5 halves, or negative 5 halves is actually negative 2.5. And the second x-intercept is x is equal to 3. And this is its equivalent coordinate form or ordered form. And then this one is the ordered form as well. Now we're ready to move on to determining the y-intercept. To determine the y-intercept, we remember that we set x equals to 0 and solve for y. We can actually use we can use any of these two equations that we have here. The one that we got, these two are equivalent equation. This one is in general form. This one is in factored form. It doesn't matter which one to use in order that we can determine the y-intercept, so that we can go ahead and just use the first equation that we have right here, and then I'm going to show the work on the side right here. Okay, so when I plugged in x is equals to 0, so the x becomes a 0 and this x becomes a 0, we're able to get y is equal to negative 15. So this is our y-intercept, or in coordinate form, that is 0 and negative 15. On the side, you will see the Desmos version of this equation, y is equals to 2x squared minus x minus 15. It can be seen that there are two x-intercept located at negative 5 halves and 0. Negative 5 halves actually can be represented in decimal as negative 2.5. And then the other one is at 3, 0. And we also have one y-intercept located at 0, negative 15. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!